Thanks, everybody, for joining us today in this session about KEDA and how to unlock new beyonds and how to use KEDA in production. First of all, I'm going to introduce myself. I'm Jorge Turrado. I work as principal SRE at SCRM, the international hub of Lidl, Sparks Group, and I'm one of KEDA maintainers. I'm also CNCF ambassador and Microsoft MVP, and he is my employee. Nice. Introduce yourself.
Thank you, Jorge. Thank you. Great. So Jorge is done for today, and the rest of the talk is on me. So my name is Zbynek. I know it's hard to pronounce, and don't feel bad about it. I'm also a KEDA maintainer. I'm with the project since the inception, so already even it was before the CNCF donation. So we together work with a couple of other folks on KEDA. On top of that, I'm also founder and CTO of Kedify. It's a company built around KEDA, and we provide enterprise autoscaling solutions around KEDA for our customers. So let's talk about KEDA today. This is the agenda we have. I hope we will be able to get it in time. So we'll have some introduction, talk about some features, discuss best practices and some challenges that you can face with dealing with autoscaling. So before we start, may I ask the audience if you can raise your hand if you already use KEDA in production? Nice. It's like more than half, right? Is there anybody who doesn't know what KEDA is, or maybe just heard the name but is not aware of the capabilities? Okay, we have a bunch of folks. And is there anybody who knows what KEDA is but doesn't use it, would like to use it? Okay, perfect. So we have a coverage for all the stuff. So let's start, right? So why do we need to use KEDA? Why do we need to use autoscaling? For the folks that already use KEDA, this will be repetition of the already known, but I would like to cover this kind of stuff in a short time. So why would we need autoscaling on our clusters? First, we would like to save resources because we would like to run only the workloads when they are needed, and also at the same time, we would like to improve performance of our applications. How we can do that? We can enable autoscaling because we can autoscale our workloads based on the actual demand. So let's take a look at this problem. We have a Kubernetes application. This application is consuming some data from some external source. In this case, it could be RabbitMQ. So the consumer application is consuming data, and we would like to autoscale it because we just discussed that autoscaling is great, right? So the naive approach, would be to plug HPA into the mix. HPA is already built in Kubernetes. It works well. It's a perfect tool. And what it does, it monitors CPU memory usage on the application, and based on these metrics, it scales out the application. This is great for a lot of use cases, but for a lot of use cases, this might not be the most ideal solution. Why? Because consuming messages from the external source doesn't reflect in the resources consumption on the workload. What does it mean? Our application is pulling data from RabbitMQ, and this doesn't reflect in the CPU or memory load. Or maybe the load is coming a little bit after. Much wiser would be to actually scale the application based on the metrics coming from RabbitMQ, Kafka, Prometheus, you name it. How we can do that? Yeah, you guessed it right. We plug KEDA into the mix, and with this solution, we can scrape the metrics directly from the external source, and then scale the workload directly. We can also scale to 0. Yeah, it's your turn now. No, I will hold your microphone.
So let's show you a demo. The good part of KEDA is that you don't need to be aware about complex stuff related with custom metric servers and how Kubernetes handles metrics and the management of the metrics for the HPA. Can you see my fuck?
No, we cannot see your beep.
It is what it is. It happens. Now I'm showing the right screen, and instead of using an HPA with boring custom metrics, with adapters and a lot of boring stuff, you just need to deploy KEDA with, in this case, I have an authentication source just for the secret. It's not rocket science. At the end of the day, we are not putting humans on Mars. So it's just a reference to a secret, and I'm going to deploy the demo. And if I go to the demo namespace, Now I have published some messages on a RabbitMQ, and then automatically it has started from 0 to 1, and eventually it will scale now for 2 to 4, then it will scale to 8, and so on, and until all the messages are consumed.
Perfect, nice.
I can dance a bit if you want.
No, please don't.
Thanks, I appreciate it. Now the messages are being consumed, and in a couple of seconds, when all the messages end, we could see how it scaled to 0 again. No, it doesn't work. It is what it is. But you are the cutest support for the microphone that I have.
Thank you. What's your vibe about it?
Nice. So it's finishing. Let me check how close it is. It's almost there. And in just a second, no problem. We can continue with our session because just another second, blah, 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 blah. Nah.
We have 24 minutes left.
24? No problem, bro. No problem. We are almost there. I don't, yeah. Scaling to 0 again, so we can reduce the money. I was afraid about doing a demo that doesn't work just in the beginning, to be honest. Let's continue with a Shift F5.
Perfect. OK, so this is KEDA in action. I hope it was somehow understandable. So what is KEDA? KEDA is a project that builds on top of Kubernetes. We try to reuse Kubernetes internals. You can scale any workloads, Kubernetes jobs, whatever, based on different metrics, not just CPU memory. We have 70 plus different event sources, so RabbitMQ, Prometheus, whatever. We have a community, a lot of folks using it. We have some good contributors. We have a KEDA user survey, so if you are KEDA user, please fill the survey so we can know, we can understand what is your opinion on the project. So, architecture. It's your turn, KEDA.
It's my turn. Okay. Oh, thanks.
Thank you very much.
So marketing stuff for the CTO, technical part for the SRE, right? The life, the world. So the point is how KEDA works. Basically, KEDA is built on top of Kubernetes. It's not replacing the Kubernetes mechanisms for the autoscaling. It's just extending them. Why? Because KEDA doesn't replace the HPA. Basically, KEDA extends the APA, the HPA, thanks to another extension for metrics through external metrics. That can be done thanks to the scale object. The scale object is just a wrapper on top of the HPA to extend the HPA capabilities. But one thing that we have noticed over the years is that not all the workloads can be horizontally autoscaled, relying on the HPA. Because if your workload have some kind of state and can't be randomly killed during the scale down process, probably you will face with troubles. For instance, if you have your GitHub runners or any kind of CI runners, that doesn't match with an horizontal autoscaling process as it is, because you cannot guarantee that the killed pod is the empty pod. For that, we developed the scale job, which it's almost the same, but instead of relying on the HPA and the horizontal pod autoscaler controller, we spawn from KEDA different jobs. So the job has to end before it's removed. Apart of these approaches, KEDA extends the horizontal autoscaling capabilities, supporting the scale to 0, which is something that you could say, but Kubernetes does support it. Yes, but not. You need to enable a feature gate, and you need to provide your custom metric in your own way. So you need to deal with all the problems and boring stuff related with custom metrics server API. In this case, KEDA does it on your behalf. And how an scale object looks, because HPA is like a common and a well-known manifest within Kubernetes. But if you check the current scale object approach, probably there are a lot of similarities and a lot of things that you can relate with the HPA. There is a scale target ref, there is the max and minimum replicas that you want, and instead of metrics, you have triggers. Which is a trigger? A trigger is the scaler that you want to use, and you can use one or multiple triggers. doesn't matter. You can include all the information that you need to make your autoscaling accurate with your necessities, not just CPU or memory. And, and almost the same for the jobs, but with some small difference. Instead of referring a workload in general, you can specify your job spec, and KEDA will spawn jobs based on your rules during the scaling process. As I said, this can bring you more power if your workloads have state, or if you are running some long-running execution, you need to keep the process alive until it ends. It's not just a stateless application. Probably this is your best fit for your necessities.
It's like a cron job on steroids, basically.
Yeah, it's like a good cron job. Features, nice features. This year has been a year probably with not super fancy features, but all those features that you could need for really, really enterprise scenarios. What do I mean? Probably, if you check other years, we could have said, no, 30 new scalar sources and a lot of auth methods extra created. But nowadays, in enterprise application, in distributed and really huge application, you need a good observability. You need a good eventing about the things that are happening. We have been working on cloud events, on supporting the cloud event specification in order to publish all the things that are happening in KEDA, but wherever you need them. Just publishing them through HTTP, through Azure Event Grid, and we are working on new targets that you can use to receive all the events related with KEDA wherever you need them. Also, we have been working on improving observability in terms of aligning all the metrics that we expose and all the flows that you can use with the community standards. Because if you work with Prometheus, or at least in my case, when I work with Prometheus, I don't like to see different kind of metrics, naming like execution hours. No, hour is not a community standard. The community standard is second, _second. So why should I work with hours? Why KEDA comes here to break the standards and make the things that they want? No, we have refactored all those metrics. We have been working on aligning all the standards with the community, and also, yeah. Do you want to continue? I need to drink.
No, continue, please.
Yeah, perfect. Yes, sir. We have been working also on improving the experience when you work with KEDA to detect the problems as soon as they happen. Working on admission webhooks. Admission webhooks were there last year, but we have improved which checks we do. We have improved multiple fixes that we have discovered over the year. And please go ahead. We have been working also on improving all the authentication stuff. We have improved the AWS. Thanks, appreciate it.
Yeah, I will continue. So basically a lot of improvements on the authentication area because autoscaling is one part, but securing the authentication and credentials and this kind of stuff is also important, because when we are talking to these external services, you need sometimes, or usually you need authentication. So we need a proper way how to communicate to these services. Okay, so this was a very brief overview of KEDA and some new features and new stuff. Let's talk about some best practices, actually, which might be interesting to you guys. So the first thing, it might be obvious, please use HPA scaling behavior. What is it? It's a feature native to HPA, which we are using under the hood, but it's important, this setting is important for one-to-end scaling. It basically controls how HPA responds to the actual load. So with this proper setting on this configuration, we can avoid fluctuations on the replicas, so number of replicas. So you see high load, low load. So you can have a stabilization window policies, etc., etc. You can also define how many pods you would like to add in a single iteration. So basically, when we are creating more pods, where we are scaling out, we can change this kind of setting. So this is very, very important setting, and this could really change the stuff for you if you configure it properly. The other, let's say, best practice, or maybe I would say one of the most repeating questions we got from our users. So they say, okay, we are using cron scaler. So what is cron scaler? In cron scaler, you can define a schedule, And you can basically tell, okay, during this schedule, I would like to have this amount of replicas. This is useful, I don't know, if you would like to scale out the workload in different ways during the day. So for example, work hours, and during the night, you would like to scale out a little bit differently. And the typical thing that usually people do is to define that they would like to scale to 0 outside of the working hours. The best way how to do that is not to define these replicas to 0 in the cron scaler, because how the cron scaler works, it tells HPA when it should scale. So it should be the opposite. So in the cron scaler, we define the minimum that we would like to have outside of this 0 schedule. So this is the important thing to do.
Actually, you can use this feature that you are going to explain to achieve the behavior of the previous slide, just in case.
Exactly. And this is also, let's say, newer feature, maybe not everybody is aware of it. It's called scaling modifiers. What is it about? KEDA internally is relying on HPA to drive the scaling. And you can, as Jorge mentioned, you can define multiple different scalars. The default behavior is that the scalar that reports the largest value is being selected to drive the scaling. So imagine you have two scalars. One scalar gives you metric to scale to 2 replicas. The other scalar tells you to scale to 5 replicas. So HPA, by default, will select the 5 as the maximum. We cannot do it about it. For example, you would like to have average. You have like the minimum or stuff like that. Because it's hard to modify this in the HPA, because of the way how HPA works, we develop scaling modifiers where you can define the needed behavior. So you can specify a mathematical formula or nested conditions, and you can really play with the different metrics. So you can use different sources, different triggers, and scale them out properly. Jorge will show you this kind of stuff in action.
Nice. This time I have done it. Thanks. So in this case, we have a super simple scale object, easy peasy, just with 2 different cron triggers for the demo. Doesn't matter which trigger you use. And if we check the metrics, if we go to the HPA, we can see that there are 2 metrics with 1 in average. This is just a super stupid example, but if you want to add them instead of executing a max between them, because you are mixing some provider queue and another provider queue, whatever you want to apply, HPA doesn't support it, as Zbynek explained. You can go to your scale object, and you can define an advanced section, scaling modifiers, where you can directly write down your custom formula, and KEDA will do the magic under the hood to provide the scaling as you want. In this case, I'm going to say scalar A plus, instead of 4, plus, 4, 2, easy peasy. And I'm going to apply it. And now I'm going to check again the HPA. The same HPA has automatically been updated. Now instead of seeing 2 triggers, I see 1 composite trigger, and the result of it is 1 plus 1 for 2. 4 is the value. This is a super stupid example, but it shows the power of this feature, because for the previous case, when I want to scale to 0, I can just define 0 as the cron and multiply for the working hours that I want to scale, or 1 for it, or those kind of formulas. The limit is your imagination in this case.
Yeah, perfect. And also I would like to highlight that this feature is not useful only when you have multiple scalars or triggers. Only if you have just one trigger and you would like to just modify the setting on this particular trigger, you can do it with this powerful engine. So if you haven't used it, please try to think about it, because it's very powerful. Okay, so this was the demo, right? No, enough. Okay, so this was the best practices, from our observation in the community, what people usually ask, what is the common issue. And this is all nice, right? Autoscaling works, everything is perfect, KEDA is perfect, Kubernetes is perfect, right? Actually, but it is not. So with the autoscaling, and especially in a larger scale, you can see a bunch of challenges and a bunch of issues in the environment, and I will try to list a few of them. So the first one, this is a really good topic actually, and so As we discussed, KEDA supports multiple different event sources. One of them is Prometheus, and I would say this is one of the most popular scarers that we have out there because it's like a flexible, it allows you to do a lot of things under the hood. Because you have already some monitoring solution in your system, right? So why don't use the metrics to drive the scaling as well? This is good. For a lot of cases, this is good, but there are certain scenarios. I would start with the first. And the Prometheus is just an example. It could be any other monitoring solution. It could be Datadog, Dynatrace. Basically, you have the metrics stored somewhere outside the cluster, and you are just pulling them. So the first problem is, if you look at the diagram, you can see that the workload is, exposing some metrics, and our Prometheus instance is scraping them. So first, we need to send the metrics to Prometheus, and then KEDA can scrape those metrics from Prometheus again. So there is like this delay, which could be a matter of seconds, maybe sometimes a minute, and it depends on the configuration. For some cases, this is completely okay because you are doing some complex Prometheus query that takes average over a long time. But if you need more real-time traffic, this is a problem because you are introducing the delay for the scaling. So it would be better to instead scrape those metrics directly from the workload. The other problem with this solution is that, especially larger scale, if you have many clusters, and for example, single, let's say, observability tool or Prometheus instance somewhere outside the cluster, you are causing a lot of traffic outside the cluster and back into the cluster. Imagine you have an application, you have the metric in the Kubernetes cluster, then you send the metric there somewhere in the wild, and then back to KEDA. Sometimes it could be cross-zone traffic. The cross-zone traffic is expensive as well on cloud providers, right? So you might cause a lot of traffic, unnecessary traffic, into your system. Other thing, since you are trying to be more real time, so you try to configure the scraping periods to be as low as possible. This is doable. Maybe your Prometheus instance is capable of handling. This is fine, but once you start overloading this Prometheus instance, you are starting getting connection timeouts in KEDA. And this is very, very typical issue we see from users that they are complaining, okay, we are getting a lot of this context deadline exceeded and stuff like that. So yeah, thank you. So and this is a really issue, and you should really think about when you are designing your solution, where you host the metrics. The other thing, which is kind of related, is that your application is scaled based on some metrics, and these applications, it could be multiple different applications, and they are all talking to the same infrastructure piece. It could be database or your service that you are hosting yourself. You might actually buy this auto-scaling stuff, which is awesome. You might overload this database. So you should think about really how to properly configure the database, maybe try to scale the infra somehow, a little bit, or control how many replicas of each applications can connect to the same instance. The other thing, cluster autoscalers, because if you would like to enable autoscaling on Kubernetes, it's important to correctly set up both pod level autoscaling and the cluster autoscaling. It needs to be every time configured together, because this is the key to enable dynamicity. Cluster autoscaler is much slower than pod autoscaler because it takes much longer to schedule a new node. So you should really think about how to mitigate this solution. There are a bunch of ways how we can do that. It's a little bit harder because cluster autoscalers, they don't have any API for us to tell cluster autoscaler, okay, let's start scaling out, creating new node. So this is a little bit harder because there is no APIs, but there are ways how to achieve that. The other thing, AI is everywhere, right? So you are hosting your, or for example, you wouldn't like to host the models in some service, for example, OpenAI or somewhere else. You would like to host the models in your Kubernetes cluster, in your infra, for compliance, security issues, or maybe cost. So autoscaling applies also to these workloads, and it's even more important because GPUs are expensive. So we need to properly think about using the proper metrics to scale out the applications to have the good latency and throughput. I recommend you a good talk on this problem. They are using KEDA, Ksurf to try to mitigate this problem, and it's tomorrow, the last talk of the day. Definitely recommend this stuff if you are interested in running your AI workloads on Kubernetes. Okay, so for the roadmap, we have a predictive scaling, which is something we are trying to do in a long time. What is the benefit? KEDA is getting a lot of these metrics about your workloads. So the idea is to get those metrics, and then based on the patterns we see in those metrics, anticipate the load. So we can scale a little bit in advance before the actual load is happening. Also, authentications, the stuff we discussed before, it's important. So this is the stuff also we would like to extend. And Jorge will continue.
Yeah, and we are in talk with AVM just to extend new platforms, more platforms for KEDA, just to support more use cases. And the last, but don't troll me. Trollers want to troll. The last but not least, the HTTP scaling. All the things that we have explained fit really, really nice with asynchronous processes. But when you are dealing with synchronous processes like HTTP requests, you need to do the things in a different way. You cannot just, no, the request is on the queue, we will process it. Not if you want to scale from zero. We are in a hurry, please pass the next slide. Fuck. HR will contact you. This is more or less the draft. If you see, the blue are the colors. Yeah, the green part is your application, the blue part is the client, the customer's calling, and the red part is how KEDA works. KEDA can interact in the middle of your workload without modifying your workload, so it's not so intrusive in terms of needing to change all your deployment way just to use the HTTP scaling features. And basically, it will deploy the interceptor in the middle. Yeah, I'm on it. So, thanks.
Welcome. Yeah, I would like to add that this also applies to the stuff I mentioned before, because HTTP traffic is more, it's more special, yeah, and the real-time aspect is more special because you have timeouts and stuff like that. So you really need to be fast when you are scaling based on the HTTP traffic.
So ending with the last demo, if I go to the HTTP demo, there isn't any pod here serving my request, but as soon as I browse, I could need, please work. Yeah, it's working. I can see that, oh, fuck, I opened the ground chat. I see the pod here, so it has a scale, and when the workload is not needed, it will just scale to 0 after some time. So if I come here again and refresh, I will see exactly the same behavior. Scaling out, reprocessing the request, and scaling in, saving money in the process. And it has been all. Thanks, everybody, for joining us today for this session. If you have any question, this is the moment. If not, if you are afraid about asking publicly, you can reach us during the process. You can ping us by Slack, by however.
Hey. Thank you.
Hi, thank you. That was really nice. You mentioned something about cluster autoscaler. And I was aware, I know what KEDA does, maybe not so well after that presentation, but you mentioned something about cluster autoscaler. How would KEDA work with a concept like cluster autoscaling? Yeah,
so we have a POC on that at Kedify. We build we are using cluster API, because cluster autoscalers, Carpenter or cluster autoscalers, it doesn't have an API to tell it to add a new node. So what we did, we have a cluster API defined on a separate node group. So you can run your Carpenter or cluster autoscaler on the cluster. You create a separate node group, and we can target this node group to create new nodes based on those metrics, all the metrics we discussed. So you can specify, for example, I can see this. The benefit is that the cluster autoscalers, Carpenter, it's kind of reactive. So it based on the resource utilization.
Unschedulable pods. That's all
yeah,
it is. Yes.
Yeah. So we try to do that in a faster way through cluster API.
So you said that's in POC right now?
Yeah. We can talk about it later on, but we have a POC on that.
Thank you. Thank you very much.
Anybody else has a question? There is a question. I'm sorry for the guy.
Hi, a question regarding the interceptors for HTTP traffic. Can you also utilize existing interceptors like from a service mesh? Because I think the service mesh would be kind of interceptor anyway, so.
Yes and no, because especially for the scale from 0 to 1, you need to hold the first request and catch it and wait until the application is scaled out, which is a bit harder with the interceptor. Any other question? Anybody? We have his. Sorry for that single mic. Do you want to take that one?
Hi. I know that Cluster Autoscaler recently introduced something called provisioning requests. Sorry, can you hear me? Cluster Autoscaler recently introduced something called provisioning requests, which I know like Q is using to basically like submit upscales like before a job is running. I'm curious if you've like thought about integrating provisioning requests with KEDA at all, because you talked a little bit about like an API to like pre-upscale. I know it's a little bit more challenging with predictive scaling with KEDA, but I'm curious if you've explored provisioning requests at all.
Yes, we did, but nothing concrete at the moment. But yeah, we saw that. Yeah, so good input. Yeah. Yeah, I will let you do it. Yeah.
So you mentioned earlier that KEDA works also with other custom resources other than deployments. Is that right?
Yep.
Yeah. So do you know a use case where it is used for CI workloads, for example, with GitHub Actions, self-hosted runners? Does it work well with those kind of situations?
So you mean like the worker, like in the GitHub, like a
runners. So I have GitHub Actions self-hosted runners running as pods in my, but they are managed with a custom resource. So can I use KEDA to autoscale them?
The question is if KEDA can manage custom resource definition or can scale custom resources, because he has a use case where they use a custom resource, an operator based on a custom resource to spin up some workloads there. The answer is, yeah, KEDA can scale whatever that support /scale is an extension that you need to implement on your CRDs, and as soon as your CRD implements /scale, easy peasy, KEDA will do it. Doesn't matter which CRD is the affected one. If it implements /scale, KEDA will do it. Any other?
Thank you for the presentation. Does the HTTP autoscaler also take open WebSockets connections into account?
I'm not fully sure right now because there is a in-progress PR for supporting. It's not merged yet.
No, it is not. Like the HTTP add-on that we presented, it's still alpha beta version, I would say. So it is. So the WebSockets are missing there. Yeah.
Yeah, I remember it's not merged. It's expecting end-to-end test before merging the feature. Yep, it's not supported the WebSocket yet.
Does the extensions are in-one or GPRC based stuff? What exactly the extensions are? So runs inside the KEDA binary or outside or add-ons? How the whole framework works?
Which extension? The scalars. All of them are already built in, and you can extend them through a gRPC interface that we expose. You can use any built-in scaler. The more than 70 scalars that we said are built in, and you can use it without any other change. Or you can develop your own gRPC server, exposing the interface that we bring, and extend with any business logic that you want. If the current scalars and the scaling modifiers feature, if they don't match your necessities, you can even develop your own server and connect it to KEDA, using your server to manage the business logic and relying on KEDA to manage the Kubernetes part of the integration.
So you manage the challenge of delay when you're scraping the metrics from Prometheus somewhere far from the workload. Then what? Maybe I missed this during the presentation, but what's your recommendation to target this challenge?
There is no single recommendation. There are multiple ways how you can do that. One of the things is we are also POCing OpenTelemetry scaler. So instead of sending those metrics over to the Prometheus, we deploy small OpenTelemetry collector, and it directly fetches the metrics from your workload. So it doesn't leave the Kubernetes cluster, and it's been directly pushed to KEDA. So this is one of the solutions how you can avoid that. The other is maybe you can try the different scaler already built in KEDA that would fit the purpose better, because the Prometheus instance might be overloaded. And the last recommendation on this front is that we have also a feature which is called metrics caching. And this feature can not improve the delay, but it could a little bit ease the load that's coming to the Prometheus, because we can reduce the number of requests coming to the Prometheus. So I recommend using this one.
How about this auto collector POC? When this auto collector POC is going to?
We have it open in our repository, like in the Kedify repository, and we will be probably thinking about moving into the KEDA organization if we discuss that, and it will be separate add-on basically. So it won't be back in KEDA, but it will be there. So if we can talk about this offline, I suppose. Oh, okay. Okay, there is a question, right? Do we have one more? Yeah, do we have one more mic? Okay.
Just wondering if you guys had plans for any more AWS services, integrating with those?
Do you have an example of a service that's not covered?
It's supported.
Is there SQS you will ask about?
Just any others that you guys were working on?
No, this is usually driven by users.
Yeah, actually, we don't have any roadmap, but it's a community-driven project. If you have any service that you would like to see supported, just open a feature request. The point is that the amount of possibilities is almost infinite across all the services, across all the projects. So we implement them as soon as someone actually needs them. Instead of just implementing 1,000 of them, we just implement on demand. Or even if you need it, you can open the feature request, and you can open a PR adding the support, and it will be implemented for sure.
Okay, so I think we need to end here. So if you have more questions, feel free to reach out to us. I'll be at Kedify booth, or Jorge will be around the venue. So thank you for attendance.